Hi, everyone, and welcome. Thank you very much for watching and being here. So, hey, I'm going to talk about Node.js, HTTP, and all sorts of things, JavaScript, for the next one or less half an hour or something like that. So let's try to be quick. So before we start, well, little bit of intro. I had a great intro already, but let's do actually a proper full intro. So I am the co-founder of CTO of Platformatic. You can find us at platformatic.dev. I am vice chair of the Node.js Technical Steering Committee, as well as a board member of the OpenJS Foundation, which is the home of Node.js, Webpack, ESLint, and I don't know, 27 other projects, Fastify 2, Express, a lot of things. A long time ago, I created a web framework called Fastify, as well as the Pinologger, which a lot of people are using right now. I worked more or less 8 years and a half as a consultant before going product, and now I'm doing a developer product. Let's see how it goes. Okay. Also, I have a nice newsletter if you want to check it out at noteland.net. Cool. So, my tagline, if you don't know me, is you are using my software. All the stuff that I maintain is being downloaded 22 billion times last year in 2023, and I'm probably on target to between 29 and 30 for 2024. I have quite a big chunk of NPM in terms of download numbers. So is that should believe me when I say stuff don't probably not relevant, but you're using my software either if you want it or not. So take it or leave it, essentially. So we are all here to answer one specific question. What HTTP client should we use for Node.js in 2024? So a lot of good options. The first thing that you can do is running the popularity context. And if you look at the most popular ones that we can see right now, we have Axios, super popular. We have NodeFetch, which is also super popular. We have GOT, which is popular. And then the old school request module, which is actually going down. And we are going to talk about that later. And we also have Undici, which is going up. What is Undici and what we should be and why we are talking about Undici? And this is going to be explained later on inside the talk. So let's talk about Axios. Axios is super popular. Okay, we have everybody has used Axios at least once. It's a great product. It's a great library. Hey, it's fantastic. It has a lot of complexity, though. It has interception. It has you can post files. You can have it's isomorphic, works both client and server. Pretty great thing. We also have the request module, which is old school. This was done by Michael very early on, and at some point it deprecated it. So request is now deprecated. So if you are still using request, you should not stop using request now. Still, a lot of you are using request for whatever reason. Stop. Next one is Node Fetch. Node-Fetch is one of the most popular option, I would say. It's it's an API that is inspired by the WhatWould fetch standard that you use in browsers, but unfortunately, it's actually not compliant to the standard. So, which is both a pro and a con. Like, it's not. It's take it with. It's both a pro because it uses Node.js streams instead of WhatWould streams, which make it compatible with all the Node API. On the con side, it's not standard compliant, so it means that it's not really isomorphic. Okay, and if you try to use this, if you depend on certain features of this library, you will be surprised when you use the same code. You try to use the same code in the browser. So it also uses the old both these and Actions actually use the battle-tested HTTP and HTTPS modules, which are also had quite a lot of overhead. It also had no support for HTTP2. Do you need it? Do you don't need it? If you don't need it, don't use it. But it doesn't if you want one. Now, part of the problem with Node Fetch is it now is ESM only. And because of that, and quite a lot of people are not being upgrading. Okay, most of the downloads are still in V2, which is the common JS version, and not a lot of download and not a lot of usage of the new ESM version. So also that to consider. I also want to thank you, NodeFetch, because they created something unique at a point where it was pretty hard. So, and it showed how many people were needed Node Fetch and fetching Node. So, yeah, thank you very much, Node Fetch. And last but not least, we're going to talk about Undici. Okay, Undici is an HTTP 1.1 client that some time ago I wrote from scratch for Node.js. What does it mean from scratch? Well, it does not use the HTTP and HTTPS module in core. It's completely rewrite of the HTTP protocol starting from the lower level, which is typically the HTTP parser, so the HTTP 1.1 parser, which in this case is LLHTTP, which is great. All of this is great. It has an API call request, very similar to the HTTP module, and it's called Undici because when I was coding it, it's long time ago. I was watching Stranger Things, and it's 1.1. HTTP 1.1, it became 11, and from 11 it became Undici, which is Undici in Italian. Yeah, not so much of and I'm bad at naming things. You see, you can find the docs at undici.nodejs.org. It's part of the Node.js organization now, and is maintained by the same people that maintain HTTP requests and the HTTP and HTTPS module in core. And we're going to talk a little bit about that later. It's also the basis. It also implements the fetch standard. It's actually the basis of what you use as fetch in Node.js. So the implementation of fetch that you have in Node.js is actually based on top of Undici. So why are we doing all of that? Okay, it's because of its improved performance. Okay, it has a split between API and connection management, and which is actually, this is great. Okay, because HTTP request and response, it was all tied up, and it created a lot of maintenance issue. And it has support for interceptors. It has, as I said, is maintained by the Node.js core HTTP team, and essentially because we think that HTTP request in core and GPS.request in core is non-fixable at this point, in the sense that every time you fix a bug, 10 more pops up. So not nice. It also now, it started as an HTTP 1.1 client, but now it also supports HTTP 2. And when we will have lower level API, we'll also have HTTP 3. So, hey, nice. Also, it supports HTTP pipelining, which is great. The cons here is it poses some underlying HTTP errors from time to time, so you might need to undo those. So why? Well, as I said, the HTTP core implementation is a total mess. It uses the same API for the client and the server, which is actually pretty bad because quite a few modules in the ecosystem monkey patches or extend the API of the server. So in fact, we cannot change the client, because if we change the client, it will we cannot change the server, so we need to do a lot of mess here. Also, the connection pooling is tied. It's public. It's part of the public API. Now, this is bad because it means then when we need to do something like HTTP chew, we cannot add it to HTTP.request because of this. And yeah, as I said, it cannot be changed without breaking Express. So if we want to save the Express library, we cannot change HTTP.request. So this is the reason why we started working on Undici, and then we added Undici.request. The goal is to be as fast as possible, because making HTTP request should not be a bottleneck for your app. It also provides a good developer experience, is highly configurable. You can use it with HTTP pipelining. It has Node.js streams. It's pretty great. And, we also use the same underlying logic to support Undici fetch, which is spec compliant with a lot of the validation test passing. And it's used What2G or web streams. So the code we're using fetch can be isomorphic. Pretty great. It also, same as before with Undici.request, it separates the protocol from the public API. So it uses the same underlying logic that power Undici.request or Undici, which we'll talk a little bit about later. And we will, and it sits on top. It builds the API on top. So it's completely separated. More than that, we have, it supports HTTP chew, same as Undici.request. And same things underneath. Is actually the same logic underneath, different DX on top. So what should we use now? Well, the question is, how can we decide what to use? Well, if overhead and throughput is something that matters for you, I have good news, okay? Fetch is fast. At least in the latest Node 22, a lot of the bottlenecks were solved. Undici.request is still probably the fastest thing you can use because it's designed for that specific purpose. But fetch is actually quite fast and definitely fast enough to be used in production. Numbers on Node 20 are a little bit lower than that. But the outcome here is very positive. The goal here is very positive. Note that we are, this is with Keep Alive enabled and HTTP pipelining enabled. HTTP pipelining is a great technique. We're talking about it now. So what is HTTP pipelining? So when you're on the web, on the browser, you have a normal HTTP connection. So you have a client and a server. You establish a TCP connection. Once the TCP connection is established or the TLS connection is established, you need to now run more round trip for that. You need to do, you can, from the client, you make a request. Then the server processes that request, send the response. And then the client can make another request after he has received the previous response. Great. But, this is low, okay? Because we are wasting a lot of time with all those round trips. Like we call this gap here the round trip time, okay? Now, why we are, but we can actually take a different approach, which is HTTP 1.1 pipelining. What does it mean? Well, we could send with HTTP 1.1 pipelining, we can send 2 requests at the same time to the server, and the server will need to queue up the responses in order. This actually saves us a significant amount of time because, as you can see here in the previous example, we were finishing at 228 milliseconds. In this example, same processing time on the server, we close at 172. So this is actually great, okay? And if you want to know more about these things, there's a nice book called High Performance Web Networking from Ilya Grigorik. So check it out. Note that the part of the problem, though, is, you can see here that they respond one after another. But if one of the requests ends up finish earlier, we are in trouble because we need to wait. They need to come back in order. So the faster one that has arrived later needs to wait to be sent back. So Undici enables HTTP pipelining. Well, it's not enabled by default, but you can enable it if you want. It's actually very good for perf. Okay, and you should really, really, really using it. I think, especially for microservice to microservice communication. So when we're working on Undici, we wanted to provide the foundation for what HTTP would look like in Undici later in the few years, and we created a clear separation between from the API needed by the user and the internal. These two things are separated, so we can have multiple public API with different developer experience and performance profiles. Now, this is critical because you need to have this, okay? Otherwise, you need to abstract from the protocol to support HTTP2, for example. So, in fact, all the internals are callback-based, but not error-back-based. So, in fact, we are passing out big objects that have an on-error method to call with an error, okay? Which make it a little bit odd to work in instead of the internals, but the benefit is performance. So, hey, you can also use this to manage a connection pool, which is great. And yeah, it's built to be fast. So the key part of this logic is what we call a dispatcher, okay? So we have two bits. There is a dispatcher, which is the generic API, and then we have an agent, which is a dispatcher that manages the actual connection. Okay, you can have a dispatcher that's not an agent if you want, probably not so useful, but you can. Or you can have multiple agents that wrap each other, and we'll talk about that in a second. So you can create your agent, and then you can do the request. And you can, or fetch. This is kind of the same. You call set global dispatcher agent, and that agent will be applied to all request and fetch calls. Now, as I said, the key things are dispatchers. So we have an abstract dispatcher. A dispatcher is an abstract class. A dispatcher base, which is a little bit more methods in here, and we have a few other classes. So we have the client. The client it manages one TCP socket. That's the goal. The client manages one socket. Okay. Then we have the pool. The pool is a bunch of clients, okay? And we can have a normal pool, which is great, but we also have a balanced pool, which is a very fancy algorithm to automatically select the client that had the best historical performance. A lot of maths involved, and I need to drink something because, yay. We are omitting some here. We have the mocks and a bunch of others. So the key function here, the key point here is that the dispatcher has a dispatch function that takes the options and a handler. A handler is a very special type of interface or class or whatever that implements, that allows you to have a very good DX on top. We have the dot request that will actually use internally a request handler, a stream that will stream handler, fetch handler. Hey, okay. Great. How does the handler look like? Hell of a lot of things, okay? There is actually a lot of things here in this interface. Yeah, you see it. So, but typically you don't need to manage too much of it. What you do is there are a bunch of default interceptors. So you take your agent, then you compose those interceptors. So you take, for example, you want to handle redirection, you just configure your agent to do the redirections and even retry if needed, and it's great, okay? And if you want to use it in request, you can do agent.request or pass a dispatcher option with this, or with fetch, you need to pass it as an option, or call set global dispatcher for setting the dispatcher. Pretty great. And how our interceptor built? Well, it's quite easy actually. You will need to have an handler, and basically an interceptor is a function that returns a function that returns a function. Wow, a lot of functions. Yeah, I know. Okay, so the first function contains the option of the interceptor. The second function, it's called when the interceptor is actually initialized by the system, and it will pass in a dispatch function. Then we do, there is the final function, which is the interceptor, which it's you just take an option and a handler, and that's it. So you can build all kind of interceptors. And for example, a few months ago, I wrote a OIDC interceptor, and there is a few videos of me doing it on YouTube. So pretty good. I did it live on Twitch on my channel. Yay, that was great. And then yeah, that's it. That's good. Okay, if you want to try it out, you can remember to use the OIDC provider module if you want it. It's great, and it gives you an OIDC thing. So wrapping up, I said I'm co-founder and CTO of Platformatic. It's a new startup, and we've been around a couple of years. And we help you build APIs and consume those APIs. So, in fact, we want to help you with all the things that are not valuable features. So, from writing API clients to databases to all sorts of things. So, to recap, imagine that you want to move from you're on a journey, okay? And Platformatic help you move very fast from A to B. By using like using an high-speed train. But despite other solutions like that, it doesn't limit you, and in fact, you can actually move very fast from there on, like you get a very quick SUV. So kind of the best of both worlds, if you leave it for me. So okay, I'm going to do a demo. So I would like to try the demo gods. Okay, so if the demo gods are with me, okay. So here, let me see. I need to do this. Okay. So I have a little bit of a Platformatic DB instance running, and this instance is an open API system. Okay, maybe I need to do even more. Okay. So basically, I have an API to manage movies. So you can get a movie, okay, and a lot of parameters here. You can create a movie, okay, with a title. It's basically a table with a title. And update a movie. So pretty great, okay? Now I have it running, as you can see here. So let's try it out, actually. So let's say that we can create a movie. So here we want to try it out, and we create a movie here and call it Star Wars. Send, and you can see it here, it was created. Wow, okay. So we have it, and so the API, we have an API, okay? How do we consume this API easily? Well, pretty great, actually. So what we do is here, we can, here we go. So what we do, we call Platformatic client --frontend with the URL of the dependency, and name movies, we call it movies. And yep, we have this, okay, and CD movies, okay. Now let's take a look. This is a tiny client that is built for Node.js. It was generated for us. It also has its own types. Pretty good. So what we can do is we can create a test.mjs file and do import build from. Okay. Then we do that. Then const res. Oh yeah, I need to pass in the URL of my API. Yeah. Then await movies. You see get movies. Yep. And then we can console log res. Let's run this. Will it run? Okay. Ooh, you see, it didn't. Here we go. Okay, it's actually working as expected. So we can actually, it's actually very easy to create and use a client here. The client is as Node apps. So, and it's actually built on top of, Fetch. which is, probably the best recommendation to use in Node.js in 2024. So, and with that, I would say thank you very much. Thank you for watching. And we are Platformatic. Thank you very much. Let's see here. Hello. So probably I got the audience by the organizer by surprise by finishing a little bit earlier. Ouch. I can show you more stuff. Okay, great. Let's do that. Okay. So here you can see we have used this client. However, you see that I created with Frontend. So I can actually create one without it. So let's run it again. Call it movies 2. Okay. So now if you go to movies 2, this is actually quite different. So the package that we created, it's here. You see it use a module called platformatic./client. Okay. And it's literally set up in slightly different way. Why? Because if we are on the server, we can actually use a slightly different implementation. The things here are, to be honest, very similar in reality. So what we can do is, okay, let's do a test.mjs. So I need to do npmi at platformatic client. Here we go. Okay. So import build from movies 2. Okay. And I need to pass in a URL. Okay. Okay. And now const res await client dot. Oh, yeah, I need to do like this, maybe. Let's see. This return. Let's see what it returns. And yay. Ooh. Oh, yes, it is. It's a common JS module. Oops. Made a mistake. 11. This is the problem. Okay. This is okay, true. So this plugin is actually set up for running inside my web framework called Fastify. So I need Fastify here. Here we go. So this is useful if you have a Fastify app and you can, okay, so here. Okay, import Fastify from Fastify. So const app. Okay, here we go. App dot get slash. Okay. And here rec dot movies 2. You see that there is there get movies. And so return movies. Okay. App dot listen port 3000. Here we go. Okay. So So now we can do node test. This is running my app. And if I do, I'm getting the same result as before. Okay. And all of this is running using a Undici request automatically. And it's really fast. So yeah, cool. I think I'm done. So thank you very much for watching. And I think I'm right of time with the full demo. So.
And we do have a few questions for you.
Oh, amazing.
All right. Starting off with, in what scenarios does fetch not work? Practical examples if possible.
Sorry, can you repeat the question? You broke up a little bit.
In what scenarios does fetch not work? Practical examples if possible.
I don't know. You should just
Fair
use
enough.
it. I to be honest, it's it doesn't. So if it doesn't work if you are heavily dependent on some behaviors of the old school HTTP client. So there are some few cases where especially if you're consuming a very old API, you might have a little bit of trouble with using native fetch. Please report those to us. We actually want to fix them, but it's actually been very hard to identify those kind of bugs.
Awesome. And will Undici eventually support HTTP 3?
Yes, absolutely, 100%.
And what's the key to speed of Undici?
Back in the days around 2016, 2017, I did a lot of research with a few other friends on writing very fast JavaScript applications. And it involves a very not DX friendly, not developer experience, not developer friendly style of writing those, especially using large state objects with a lot of properties and functions in it. And this is how Undici is set up. So possibly minimize all allocations. This is one of the generic bits, and make sure that all objects are short-lived as possible to ease the garbage collector. So it's a lot of low-level stuff, and on top of that, a queuing algorithm for selecting the socket that actually works better and is faster than the previous generation. So yeah.
All right. And last question, considering the rapid evolution of web technologies, which HTTP client do you think will be the most future-proof and why?
Oh, well. They are for me. The answer is quite simple, but I would leave I would be our viewers to decide.
I like it. I like it. Well, thank you so much for your time today, Matteo. We greatly appreciate it.
Thank you. Bye-bye. Bye.